So here's the problem number 1 of second tree assignment, and in this problem we have to we're given a binary tree or a binary search tree, and using this binary tree we need to create a linked list of each depth of a tree. So for example, we're given this binary tree and we need to create 3 linked lists. Like first one is 4 with 1 node, because in the root is just 1 node. Second linked list will be from the next row of a binary tree, so it will be 2 and 6, and the third linked list will be just the linked list of all nodes from the bottom of a tree. So this one will be third linked list. So in order to solve this problem, I will be using a queue. So this queue will be used to store all nodes from each depth. Also, like here, I just put this definitions of tree node and list node, because during in our algorithm we will be converting not tree nodes into list nodes, because in our result we will need to return linked list. So queue. So first of all, I will just push the first node into our queue. Then I will convert this tree node into this list node. After that, while my queue will not be empty, I will just define header pointers and current pointers of list node. If my head will be null, so I will just pop it from the queue and push it to the head. Also, I will use a list to store all my linked lists. So after that, after my queue will be empty, I will just put this head list node into my list. Then before storing into my linked list, into my list, I will check if my tree node have children on the right and on the left. So in this case it has children, and I will push its children to my queue, and then I will restart my while loop with empty headers and current pointers. At this point I will pop value from queues, convert it to list node, push it to the header, also push it to the current. Then I will again pop the value from queue, and since my header is already full, I will just move my current pointer to 6, and after that I will just store a new list node into my list. So this will be a head 2, and again I will just before storing it to my list, I also will push the children's of my tree nodes, of my currently considering tree nodes. So just after being done with my last node at this depth, I will just push children's of those nodes into my queue, and again I will reset my header and current pointers to null, and accordingly push the values from my queue into this list pointers. So at the end, I will just push the output into my list, and as a result, I will just return the list with the list node headers. So how it's gonna look like on a code, let's see it. So return will be a list of list nodes, and I call it list. Oh, no, so it's just a list of list nodes, and it will be called convert binary tree to linked list. So input will be just root of tree. Here I will initialize a list. I will call just a list. It will be new list, which will be consists of list nodes. Then I will declare a queue, which will be storing the tree nodes, and I call it just queue. Also, I will need a counter, like just to see at which level of the binary tree we will be at, and after that we will be doing the initial check, like checking if our root is null. If it's null, we will just return null, like empty list. So otherwise we will push first root value to our queue, then we will initialize while loop, and this while loop will be running once it's not empty. So here our level, which we declared here, will be equal to queue, the number of nodes in our queue. Then we will initialize, declare head pointers, header as a pointer. Initial value will be null, and list node current initial value will be also null. Then we will be initializing our again a while loop, just to go through all elements in our row. Just our while loop will be running until level is greater than 0. So here tree node, we will declare another tree node, a temporary node, and it will be popped from our queue. So at the beginning it's just a root node, then we will initialize list node. I call it just list node, and into this list node we will just push the data from our node. So basically we're converting our tree node into list node, so node data. So we're taking the data from tree node and pushing, setting it to our list node. And after that, we're like setting this list node to our header or current pointers. So if header is equal to null, then our head will be equal to list node, the node that we just created here, and also our current will be equal to list node. Else, if we already stored some data on our header pointer, we will just move our current pointer, like current next list node, and resetting our current to the last node of our linked list. And so just I will continue on the next page, and we will check if our node has childrens. If it has childrens, then we will just push these childrens. Like first we'll check if it has left child, sorry. So if it's not equal to null, so if it has a left children, we will push it to our queue. And the same thing will be done with the right child. So we will be checking for the right child, and if we have right child, we will just push it to queue. And after that, we will just decrement our level variable, which we already declared here. So because once we're done with one of the rows here, we want to initialize a new loop for redefining our new linked list. And after that, just when we are done with this while loop, so meaning that we're already defined one linked list from one depth of our tree, we will just push. In our case, we will add the header, the head pointer of that linked list into our list, and we will just be doing it with each depth of our tree. So we will be just push first head of this depth, then we will push header head list node for this depth, where we will just pushing the head word of 2 of this linked list, and then we will be pushing to our list this linked list. So, and after that, after we will be done with all nodes of our tree, we will just return our list with the linked list.